Chapters 3, 4, 5, and 6 are all going to work towards and then deal with fractions. So we're going to start with divisibility rules. So, we're going to learn divisibility rules for the numbers 2, 3, 4, 5, 6, 8, 9, and 10. The only basic numbers we're skipping are 1, because everything is divisible by 1, and 7, because the rule for 7 is incredibly complex. No, I'm not going to go over what it is. So, the rule for divisibility by 2 is that the last digit must be even. The rule for 3 is that if I add the digits up, I have to get a number that can be divided by 3. The rule for 4 is that the last two digits are either 0, 0, or they are a two-digit number that is divisible by 4. For 5, the last digit is either a 0 or a 5. The rule for 6 is simply that you must work for both 2 and 3. The rule for 8 is that the last three digits are either 0, 0, 0, or form a three-digit number divisible by 8. The rule for 9 is similar to 3 in that you add the digits up and say, can I divide by 9? And the rule for 10 is maybe the second simplest of them all, or the simplest. The last digit has to be 0. So we're just going to tell if each of these numbers is divisible by these various numbers. And we're going to do a chart to show this. So rather than saying, is 690 divisible by all of these, I find it easier to say, okay, the rule for 2 is that your last number must be even. So the last number of 690 is 0. That's even, so that's fine. I'm left-handed, by the way. My check marks will be backwards. But that's a check mark. 4, 3, 5. 5 is not even, so that does not divide by 2. 702, last number is 2, that's even. 9136, his last number is 6, 6 is even. The rule for 3 says that you need to add these all up, and can what you get divide by 3? So 690 is 6 plus 9 plus 0. That's 15. Does 15 divide by 3? Yes, it does. 4 plus 3 is 8, plus 5 is 13. Does 13 divide by 3? It does not. 7 plus 0 plus 2 is 9. Does 9 divide by 3? It does. And 9 plus 1 is 10, plus 3 is 13, plus 6 is 19. Does 19 divide by 3? It does not. The rule for 4 is that your last two digits are either 0, 0, or a two-digit number that does divide by 4. So the last two digits of 690 are 90. That's not 0, 0. And 90 does not divide by 4. 4 goes into 88. 4 goes into 92, but 4 does not go into 90. The last two digits of 435 are 35. Definitely doesn't divide by 4. The last two digits of 702 are 02. 02 does not divide by 4. And the last two digits of 9,136 are 36. 36 does divide by 4, so this finally gets a check mark. The rule for 5 is that your last digit is either 0 or 5. So 690 is okay, 435 is okay, but 702 and 9,136 are not. The rule for 6 is you must work for both 2 and 3. So if 2 and 3 both have check marks, 6 can have a check mark. So 9136 does not get a check mark on 6 because it doesn't work on both 2 and 3. It only works on 2. We're going to skip 8 for a second because it is, quite frankly, the biggest pain in the butt. The rule for 9 is add up the digits and does it divide by 9. So 6 plus 9 is 15, does not divide by 9. 4 plus 3 is 7, plus 5 is 12. 12 does not divide by 9. But I just have to go back and I realize something. 4 plus 3 is 7, 7 plus 5 is 12, 12 does divide by 3. So if anybody was hollering at me that this box should be a check mark, you are correct. We've now fixed that. 702, 7 plus 2 is 9. 9 does divide by 9. And 9 plus 1 is 10, plus 3 is 13, plus 6 is 19. 19 does not divide by 9. And 10, let's see. Last digit has to be 0, so that only works for the first number. Now, 8 is, the last 3 digits must be 0, 0, 0. Well, that doesn't happen in any of these. Or the last 3 digits must form a number that is divisible by 8. Great. So the question is, does 690, since it's a 3-digit number, divide by 8? The answer is no. Does 435 divide by 8? Absolutely not. 702 might. But it doesn't. And does 136 divide by 8? Yes, it does. How are you expected to know that? Well, you just kind of sort of have to check. So, I cheated for the purposes of the video. I used a calculator. But you would have to do this and say, does it work? Or do you get a remainder? If it works, great. If you get a remainder, it doesn't. Hopefully, you don't have to go too hard in checking those, because if the number is odd, if 2 fails, so the number is odd, which other numbers are going to automatically fail? Well, if 2 doesn't work, then 4 can't work, 6 can't work, 8 can't work, and 10 can't work. If 3 fails, 6 and 9 automatically fail as well. You don't have to check them. If 4 fails, 8 fails. And if 5 fails, what other number automatically fails? None. 5 failing doesn't cause anything to happen. So, knowing this, if we go back up here and look at our 8s, and I erase those, because 4 fails, I know 8 fails in the first column. Because 2 fails, I know 8 fails in the second column. Because 4 fails, I know 8 fails. Since 2 and 4 both work, I actually do have to check 8 on the 9,136, which means I would do 136 divided by 8. Not just knowing the rules, but knowing what failure can tell us about bigger numbers can be very useful in this particular section.